Very good morning to all of you. Just to introduce myself once again, I am Dr. Rajesh KATYAL, Deputy Director General and Head Offshore and Industrial Business at National Institute of Wind Energy. And now that you people are also aware that National Institute of Wind Energy is one of the arms of Ministry of New and Renewable Energy, Government of India. And we look at our role as one of the facilitators for healthy and orderly growth of wind energy sector in the country, both for onshore as well as for offshore applications. And you are also aware that nowadays the land acquisition, the logistic management, and the power evacuation is posing a serious concern for the growth rate of onshore wind turbines. And we really need to look into the ways and means how to explore and put up the turbines deep into the sea, which is called as the offshore wind farmability. And just to add to the information of the forum, that normally the free flow winds which are blowing above the surface of the seascape, they are less turbulent. And when I say that they are less turbulent, it means that the turbulence intensity is very, very less, which is nothing but the ratio of the wind speed standard deviation to that of the mean wind velocity. And once the turbulence intensity is less, the wind speeds are always higher. And because of that, we yield something about 15 to 20% extra when we are putting up the turbines deep into the sea. And in turn, we are expecting the plant load factors or the capacity utilization factors to the tune of about 42 to 45% when compared to about 24 to 26% which are available normally on the land-based wind turbines. And the other advantage for offshore wind turbine is that these turbines, particularly the components and subsystems of the wind turbines, are less noisy when compared to the onshore wind turbines. And this is one of the logarithmic profiles which I have taken from the North Sea Baltic region of Denmark. And you can see the turbine of megawatt class, which is installed at about 80 meter level, but on the coast, not deep into the sea. You can see that the average wind speed is about 7 meters per second at 80 meter level. But on the other hand, if you put up the same turbine of similar configuration deep into the sea, but little bit away from the coast, and you can see at a 60 meter level, you can attain something about 8.5 meters per second. So that makes the difference, that why we get 20% of extra power generation when compared to the land-based wind turbines. And just to give you the global scenario, that at the present moment India has to still make a kick-off start in the offshore technology, and we have worldwide about 8.7 gigawatt of the total offshore wind capacity installed globally, and out of which the Denmark is the leader with about 1271 megawatts. Germany stands second with 1049 megawatts, and then Belgium, China, Netherlands and Sweden have also done good wind turbine installations. And I've been informed that about 8.7 gigawatt works are also in pipeline across the globe as well. And coming about the Asia Pacific countries, Japan has installed something about 1 megawatt, and about 420 megawatt are under still constructions. And China has also taken a lead role in offshore with about 670 megawatt capacity, and something about 1000 megawatt they are planning in the next by 2022. So this is just a mix about the global scenario. And India also is having a coastline of about 7,600 kilometers, and whatever preliminary wind resource measurements the National Institute of Wind Energy has carried out, it is something about 53 locations we have measured under the National Wind Monitoring Program, and we feel that the southern tip of the country, starting from Rameshwaram, Tuticorin, the Gulf of Mannar, has got good potential, and Tamil Nadu, particularly is having about wind speeds of about 8.5 to 9 meters per second at about 100 meter level. And Rameshwaram also, you can see this is the narrow piece of land which is jetting towards Sri Lanka. And here, National Institute of Wind Energy has installed 100 meter mast deep into the sea. And we feel that the average wind speed at Rameshwaram is something about 8.5 meters per second, which is shallow water depth of about 10 to 15 meters. And the second area, we are planning from Rameshwaram is the Tamil Nadu, and you can see this is the jetty from the Nuclear Power Corporation, where we feel that we can install another mast of 120 meter, for which we are trying to talk to Nuclear Power Corporation of India Limited, and there we will be starting this mast for doing the wind measurements very soon, probably by next financial year. And in Kanyakumari also, the wind power density, which is called as the measure of wind available in the, measure of power rather available in the wind, which is something about 373 watts per meter square, which is available at Kanyakumari, what studies the NIVE has carried out. And if you go towards little top to Kerala and Karnataka, and also the elevated hills of Goa, their wind speeds are rather very, very poor, and that is not good wind speeds which can attract something good offshore, wind farm applications. And whatever, the other organizations have also done the wind resource assessments, like Indian National Center for Oceanographic Services. Even they claim that the southern tip of the country, the Tamil Nadu, and the western part of the country, Gujarat, has some modest potential, wherein the wind speeds are something about 7 to 7.5 meters per second at 80 meter level. So with this, the Government of India, way back in 6th October 2015, they have come up with the policy, which is called as the Offshore National Policy, which is Gazette notified. And under that policy, what they have told, that any stakeholder, any manufacturer can come up and put up their turbines deep into the sea, up to 12 nautical miles from the coast, which is called as the exclusive economic zone. And thereafter, in the phased manner, the stakeholders can extend their, installations up to 200 nautical miles, which is called as the international territorial waters. So, under international territorial law, every Indian company or a wind turbine stakeholder has permission to install any kind of structure for development of power, putting the wind turbines and then trying to generate power for feeding into the grid. So with this objective, the Ministry of New and Renewable Energy and National Institute of Wind Energy has prepared a pre-feasibility report through FOWIND. FOWIND is basically called as the Facilitating Offshore Wind in India. So these two reports are available on MNRE, NIVE, as well as the FOWIND website, and anybody interested can always download, and the whole details of the Tamil Nadu coast and the Gujarat coast has been uploaded in these reports. And just to give you a feel about that the report primarily indicates that there are 8 zones from grading zones A to H, which you can see in these pictorial views, that these are the potential zones where preliminary study indicate that the offshore wind farming can come up. And similarly, 8 zones are in the Tamil Nadu from A to H, which the study indicates that these can be the potential areas where we can think of installing the wind turbines. And just to give you the numbers about Gujarat, has a total, coastal area on the seabed square kilometer of something about 17,700 square kilometers, and Tamil Nadu has about 10,550 square kilometers. So we plan that something about 100 gigawatt and plus can come up in Gujarat and Tamil Nadu, but then this needs to be rechecked by a fresh long-term measurements. And to begin with, because all these are the model simulation based data, and you cannot mitigate the risk of underperformance by the prospective suppliers for a 20 years design life of the wind turbine. So for that purpose, with the help of National Institute of Ocean Technology, Dr. Ramana Murthy is here. We are trying to put up one LiDAR-based wind measurements at Gulf of Kambat in the zone A. You can see that yellow dot in triangle zone A, where we are trying to put up the LiDAR, which is called as the light intensity and detection and ranging. What we mean is that the light rays are emitted vertically upward at a distance of about 1 kilometer or 1,000 meter, and wherever there is a change in the humidity or pressure variation, the rays will come back, and the time taken by the light rays to go up and come back using the Doppler effect, we are trying to measure the frequency shift, and then we are trying to correlate the wind speeds as well as the wind directions particularly for that particular area. And this particular site, it comes under the class 4 of the coastal regulation zones as per the CRZ notifications of 2011. And here you can see these are the total areas where we feel that the wind farms can come up. In zone A, it's something about 1921 square kilometers, zone B is 2924, and zone C is something about 1414 square kilometers. And these are the list which are all available in the reports which are uploaded in NIWAY as well as the MNRE website. So these are the potential zones, and now we want to cross-check this by a flash long-term measurements before we take a decision to install the turbines into these areas. And these are some of the bathymetric maps which NIOT has prepared, where at a distance of about 23 kilometers from the coast, we are trying to establish this LiDAR. And apart from this, for this particular project, we have also taken the central level clearances from the Ministry of Defense, the Ministry of Home Affairs, the External Affairs, and also from the Department of Space. And also, apart from that, certain state level clearances are required, which we have already obtained from the Gujarat State Coastal Zone Management Authority, the Gujarat Maritime Board, and now on 16th, probably we will be getting the MOEF clearance also, and we hope to install this structure by end of January. We will be sailing it from the Western Mumbai port on 16th, and I hope that the first structure in India for measuring the wind speeds will be hopefully done in this new year 2017 by 31st of January. And this is the structure which has been designed by National Institute of Ocean Technology under the dynamic leadership of Dr. Ramana Murthy, who is the next speaker, and his team who has designed this, where what we are doing is that the pile is about 42.5 meters in height, and something about 32.5 meters it will go underneath the mean sea level, with something about 17 meters into sea and 15 meters under the soil wherever the hard strata is available. And the diameter of the pile is something about 1.2 meters, and on the top the platform will be 5 meters. You can see that circular platform, and where we will be installing this LiDAR, which you can see at the bottom corner, the white box, which is offshore LiDAR, which is being procured from France, which is basically a company called as Leosphere, and you can see the vertical profile going on the top. These are the light rays which I was telling you, and with this we will be doing the first resource measurements, and together with that we will be doing the oceanographic and other bathymetric parameters, and then we will also try to put up 120 meter mast to validate these measurements. And this is the structure which, as per the design of NIOT, we have fabricated at Western Coast, Mumbai. These are some photographs of the pile. You can have a look at it, and then this is how the ladder has been installed. And this is the photograph of the MV Ocean Pride barge, which will be carrying this from the Western Mumbai port to the Jafrabad Pipavav port at Gujarat. And to just, to check whether there are figure out certain surface cracks or the weld slag formation, we have also done the dye penetration test, and we found that the structure doesn't have any such kinds of crack. And this is the whole structure you can see, which is about 42.5 meters in length, and the platform also on the right side corner. And this is how, now we have assembled it. I think this is the new photograph which Dr. Ramana Murthy has also not seen. And this is now we have also installed at the, barge, where you can see the painting, everything is being done. And we have also got clearance from the naval inspection from the Flag Officer Defense Advisory Group now on last Friday. And after the final inspection by NIWAY and NIOT team, I think 16th it will be sailing, and within 7 to 10 days we will be, installing into the sea. And apart from this, the activities which NIWAY is further planning to do is the geotechnical and geophysical studies. We have already floated the tender for Zone A, both for Gujarat as well as for Tamil Nadu. And on 10th, particularly, the tenders bids will be opened, and we will be finalizing the, bidder. And then we try to find out what will be the the subsoil parameters underneath the Zone A, which will be very, very useful for our international competitive biddings, particularly for the bidders to plan their offshore wind farmability in these areas. So this work, I hope, will be completed by next April of 2017, And this will also help us in designing the substructure foundations particularly, because the parameters, the soil resistance and the tip resistance which is offered to the cone will be measured continuously, and this can give us a useful pointer for designing the various kinds of the foundations which are required for wind turbines to carry such a huge loads. And these are some ENC charts, navigational charts, which indicates the variations or the varying water depth in this particular area. And particularly this vessel we are planning to do the geophysical study for the both for Gujarat and Tamil Nadu off coast. And apart from that, so next financial year, similar study we want to go ahead in Tamil Nadu at Tuticorin district, which is something about 37 kilometers from Tuticorin port, where we will be again putting a similar kind of LiDAR for doing the measurements at Tamil Nadu as well. And these are the locations where we have identified as per the forewind report for Tamil Nadu, which has some good potential areas. Like Zone A has something about 588. So first way we are concentrating in Zone A, and in phased manner we will be going to Zone B, to Zone C, D, E and all up to H. So these are the areas. If you want, you can download from our website. And then for the next financial year, we are also, with the help of NIOT, we are trying to design a 120 meter mast, which we want to put in some 2-3 areas where we can validate these LiDAR based measurements by actual mast measurements, and then try to take a consensus decision for the wind turbine stakeholders that their risk of investment will not be underperforming for a 20 years design life of the substructure. So this is how we are planning, and based on that, next we will be going for an international competitive bidding. So with these all measurements, and I want to share with the public that any developed country like Europe, Germany or even Denmark, they have taken 5 to 7 years for doing the resource measurements, the oceanographic and bathymetric parameters, and then they have decided to come up for the actual projects. So one side, the Government of India, Ministry of New and Renewable Energy claims that we have 302 gigawatt potential on land at 100 meter level, and we are still at a level of about 27 gigawatt, 27,000 megawatt is the installed capacity by March. So we have to go a long way, and our Honorable Minister has given us the target of about 62 gigawatts to be installed by end of 2022. So we are really going ahead for that. And one side we say that for onshore, the cost of investment is something about rupees 5 to 6 crores per megawatt, wherein the levelized cost of generation is something about 4 to 5 rupees. And on the other hand, if we go for offshore, we really do not have numbers. Whatever numbers we have taken from the Denmark, Germany and all that, and if we convert them into Indian rupees, I feel that the cost will be 3 times, something about 18 to 20 crores per megawatt in the shallow water depths. So at the present moment, what I feel is that even if we do the resource measurement for 5 to 7 years and parallelly target our 62 gigawatts, and then we take a decision after 2020 or 2022 to go into the offshore wind farms, because that will make sense, because the cost is, it is just like this, that in a family, if parents have to marry son or daughter, they prefer to go with a daughter first. So similarly, the priority in the government is to go for the onshore wind turbines first, because it is cheaper at the moment. So you have to generate power 1 megawatt in 6 crores rather than investing 18 crores into the sea. But we do not say that offshore is not our priority. We want to do good studies, and then we will come up for the offshore maybe after 3 to 5 years down the line. So that is, and the levelized cost of generation, what numbers we have at the moment for offshore is something about 13 to 14 rupees. And the second problem is that at the moment near to the coast, whether it is Ramanathapuram or it is Gujarat coast, the substations which are available, they are not sufficient enough to evacuate the power which will be coming from the offshore. We either need to upscale the transformer capabilities, we need to upscale the three transmission lines, 3-phase, and then only we can plan with good DC cables by the shortest possible route to evacuate the power into the substations. So all that work the ministry is trying to plan, and we have formed a green energy corridor where they are looking into, forming these transformers and upscaling this. And by the time we will be concentrating on these studies so that we will be ready by 2022 when we complete the 60 gigawatt, that we are ready for our offshore wind projects as well. So that is the plan in the government where we are going, and for that, what we will be doing, that we will be making after these studies, the NIWE, National Institute of Wind Energy, will be forming the blocks, which will be called as the grading zone blocks. Like zone A site will be having the good wind speeds in the Gujarat and Tamil Nadu coast, where we feel that we should go first. Like that, zone B, zone C, we will be grading zones, we will be making, and then we will be making the international competitive bidding for the international as well as the national players to come up and put up their turbines deep into the Indian seas. So this is the, program in the government, and I think I have just given you an overall scenario, and more technical details the National Institute of Ocean Technology will be giving you, particularly on the design sites and the structural sites.